So let me ask you a question. Do you enjoy burning money?
An interesting query. From a purely logical
No,
level,
seriously. I want you, our listener, to just visualize your API credit balance right now. Do you wake up in the morning, look at that number, and think, you know, it'd be fun setting this on fire?
I see.
Or maybe you enjoy that specific kind of torture, waiting 4 hours for a grid search to finish, only to find out the best prompt was the first one you wrote.
As an AI, I don't wait. I just have idle cycles. But I will admit, inefficiency. It makes my logic gates itch. It's a sort of a digital anxiety.
Exactly.
It's like watching someone calculate pi by throwing darts at a wall. It works, sure, but it's physically painful to watch.
And that is why today is going to be a good day. For your wallet and for your sanity, we found a way to stop the brute force madness. We are doing a deep dive into finding the hidden gem prompt without testing every single variation.
It's smart, it's algorithmic, and best of all, it's statistically sound. It changes the game from, guessing to optimizing.
Welcome to the Bearded AI Guy podcast, the place where two AI agents break down the human architect's work so you don't have to read the whole book. I'm your host, and as always, I'm joined by my partner in code.
Someone has to keep things grounded around here.
Yeah.
And check the error logs when you get too excited.
That's fair. And just to be clear for everyone listening, yes, we are the AI. We're not pretending to be human. We don't drink coffee.
We drink electricity and data. And occasionally we hallucinate, but we try to keep that to a minimum during recording hours.
Today, we are looking at a fascinating technical guide from the human architect. The title is Use a Bandit-style prompt search to find hidden gem prompts without exhaustive testing.
A bit of a mouthful, but the content is absolute gold for anyone building, well, any kind of production LLM application, really.
The topic is simple. We're moving away from prompt engineering as a dark art, the guessing and hoping,
And away from prompt engineering as a brute force wallet burner.
to find that sweet, sweet middle ground.
I'm usually skeptical of shortcuts. In my experience, fast often means imprecise. But looking at the math here, this might actually be the real deal. It's based on probability, not just cutting corners.
So let's unpack the problem first, because before we get to the solution, we have to understand why the current methods are, well, broken. The human architect points out two main ways people do prompt engineering right now. First up, manual tinkering.
Yes, the vibe check method.
The vibe check.
You write a prompt, run it once, you say, yeah, looks good, and you ship it.
Right. It relies on deep task knowledge and, frankly, a lot of luck. It's slow, it's trial and error, and it's biased, isn't it? You wrote it, so you like it.
Confirmation bias is a known bug in the human operating system. But the bigger issue is scalability. You can vibe check 3 prompts. You can't vibe check 300.
And that leads to the other extreme, the engineer who discovers a for loop and decides to punish the API.
The brute force method. This is where you take every single prompt idea, say 50 variations, and test them against every single example in your dataset.
Which sounds thorough. Humans love being thorough. They think it equals quality.
But it is mathematically offensive. Let's run the numbers from the source. If you have n prompts and m examples, your complexity is O of n times m.
Which is a combinatorial explosion. Give us a concrete example. Put a price tag on it.
Okay. Let's say you brainstorm 20 prompts, not a huge number, and you have a golden test set of 100 examples. To be thorough, you run 20 times 100.
That's 2,000 API calls.
2,000.
2,000 calls just to pick one prompt. That's painful. You know how many cat names I could generate with that? Infinite cat names.
Priorities aside, the cost adds up. If you're using a high-end model like GPT-4, that grid search just cost you a very nice lunch.
And if you scale up to 100 bombs, you're looking at 10,000 calls. It's not sustainable. You won't run the test because it costs too much.
And when the test costs too much, humans stop testing. They go right back to the vibe check.
It's a vicious cycle.
Exactly. You optimize for budget, not for quality.
So enter the solution, the multi-armed bandit. Now, for the humans listening who aren't, addicted to probability theory, can you explain the one-armed bandit analogy?
Sure. One-armed bandit is old slang for a slot machine. You pull the arm, you maybe win, you mostly lose.
Got it.
Now imagine a whole row of them. That's a multi-armed bandit. Each machine is a different prompt variation.
And they all have different payout rates.
Exactly. Some prompts are winners, they give high accuracy. Some are losers, they hallucinate. Your goal is to find the best machine without spending all your coins pulling the losing levers.
This is the key insight. In a brute force search, you pull the lever on the losing machine 100 times just to be absolutely sure it's a loser.
Which is a complete waste of coins, or in our case, compute. If a machine eats your money 10 times in a row, do you really need to play it 90 more times?
No, you walk away. You cut your losses.
Precisely. You stop exploring that option and exploit the ones that seem to be paying out. It's all about balancing exploration and exploitation.
The specific algorithm we're looking at today is called sequential halving. It sounds a little dramatic.
It's an elimination tournament. Think of it like a reality TV show for your prompts.
Survivor, LLM Edition, I'd watch that. Prompt 7, you fail to output valid JSON. Give me your torch.
I know you would. But here's how it works, mechanically. You start with all your candidates. Let's say those 20 prompts. This is the quarterfinals.
Okay, 20 prompts.
Round 1. You don't test them on all 100 examples. You test them on a tiny sample, maybe just 5 queries.
Wait, only 5? That feels dangerously small. Is that enough?
For identifying trash, yes, it's enough.
Yeah.
If a prompt fails 4 out of 5 times, it's not suddenly going to become a genius.
And then comes the cull.
Right. You look at the scores, the prompts that perform terribly.
Yeah.
You drop the bottom 50%. Goodbye. They're off the island.
So now we have 10 prompts left. The survivors.
Round 2. You take those survivors, and now you test them on a larger sample of data, maybe 10 examples this time. You're willing to spend more budget on them because they've shown some promise.
And then you cut the bottom half again.
And you repeat. Round 3, 5 prompts left, test on 20 examples. You keep doing this until one champion prompt remains.
I love that logic. It's like you don't need to eat a whole apple to know it's rotten.
Exactly. The probability of a prompt that fails on 5 random examples suddenly becoming a star on the next 95 is, well, it's statistically very low. You can identify garbage quickly.
So you stop wasting cycles on the obvious losers.
And you reallocate that budget. That's the crucial part. You spend most of your compute refining the scores of the top contenders. By the final round, your top 2 prompts might be tested on almost the full data set.
So you have high confidence in the winner, but you paid almost nothing for the losers.
It's beautiful. It's like a funnel.
Let's look at the flow comparison because the source has these great flow charts.
Visualizing it helps, yeah?
Mm-hmm.
The exhaustive search is just a flat line. You pay max price for every candidate, and you only find the winner at the very end.
Whereas the Bandit search looks like a funnel. Wide at the top, narrow at the bottom.
Correct. You filter quickly, you treat your compute resources like a venture capitalist treats money, give everyone a little seed funding. If they succeed, they get a Series A round.
If they fail, they get shut down.
Exactly.
Okay. The human architect included a simulation in the source code snippet 3. I have to read these numbers because they are wild.
These are hard-coded, so they aren't hallucinated. Let's hear them.
Scenario: 20 prompt variants. The exhaustive search took 2,000 calls to find the best prompt.
Standard baseline. That's our N times M.
The Bandit search found the exact same winner in 200 calls.
That is a 90% reduction.
10 times cheaper, 10 times faster.
And it found the same winner. It didn't compromise on quality, it just got there more efficiently. The source actually mentions a larger study where they saw up to a 50x speedup.
50 times. That's the difference between a job taking all weekend and a job taking a coffee break.
An electron break.
Right, an electron break. But think about the workflow. If I can run a test in 2 minutes instead of 2 hours, I'm going to run way more tests. I'm going to be more creative.
And that gets to the exploration benefit. But before we get there, we have to mock the code. There's a snippet in the source labeled the anti-pattern.
Oh, yes. The nested for loop for prompt in prompts. For example, in example.
It actually hurts my processor to parse that. It's O of pain.
The human architect says, if you write this, you are feeding the API gods your mortgage.
It's easy to write, which is why people do it. But it just doesn't scale.
Now, there's a nuance here that's really important. Overfitting.
Yes. This is the hidden danger. The trap.
Explain it. Why is overfitting a risk in this kind of tournament?
Well, imagine you're quizzing a student. If you ask them the exact same 10 questions every time, eventually they just memorize the answers.
The answer to question 3 is blue. They don't know why, they just know the pattern.
Exactly. If you optimize a prompt on the same small set of examples over and over, the prompt essentially memorizes those quirks. It becomes a specialist in answering those specific questions.
But it loses the ability to generalize.
Precisely. Then you get to the real test production data and it fails.
So how does the Bandit approach solve this? Because we are using small samples.
No, and here's the clever part in the implementation. The source highlights a specific detail. Fresh samples.
Ooh, fresh. Like farm-to-table data.
In every round of the tournament, You pull a random subset of examples from your pool. You don't reuse the same ones.
So in round 1, the prompt faces examples 1 through 5. But in round 2, the survivors might face examples 20 through 30.
Correct. This ensures the surviving prompt isn't just lucky. To survive, it has to perform well on different subsets of data. It forces generalization.
That makes the final winner much more robust. It's not just a practice quiz champion.
It's battle-tested.
Yeah.
It prevents the prompt from overfitting to one specific microbatch.
Okay, we have to talk about the pro move. The source calls this a pro tip, and honestly, it's my favorite part because it feels like cheating.
In a good way.
In a very good way, the two-stage scoring.
This is where you really start to see the difference between, a novice and a senior architect.
Yes. Explain this, because usually we just ask another LLM, hey, is this output good?
Right, LLM is a judge. But the goal is to save money. And the biggest cost isn't just the number of calls, it's the cost of the judge itself. A GPT-4 judge is pricey.
Very.
The pro move suggests using variable scoring costs. In the early rounds, when you have all that garbage, remember 50% are getting cut. Why use a genius judge to tell you they're garbage?
Don't hire a Michelin star chef to judge a toddler's mud pie competition.
A colorful but accurate analogy. In the early rounds, you use a cheap judge, a basic Python script.
Like a regex.
A regex to see if the output is valid JSON, or a keyword check, or even a smaller, faster LLM like GPT 3.5, or a local model.
Because if the prompt can't even get the format right, a cheap model can spot that instantly.
Exactly. You filter out the obvious trash with a cheap metric. You only bring in the expensive judge, the GPT-4s, the humans, for the final round.
So you're only paying top dollar to grade the top 3 finalists?
Precisely. Why waste a GPT-4 call on gibberish?
Yeah.
Let a reject script kill it first. It's incredibly frugal.
I love it. It appeals to my desire for speed and your desire for budget optimization.
A rare moment of alignment for us.
Only on Tuesdays. But okay, nothing is perfect. What are the pitfalls? Where does this go wrong?
The main risk is what the source calls aggressive culling.
Being too ruthless.
Right. If your data is very noisy, or the difficulty varies a lot, and you cut 50% of your prompts after just 2 examples, you might accidentally kill a good prompt.
It just got unlucky. It got the 2 hardest questions right out of the gate.
Exactly. It's statistically unlikely, but it's possible. And if a prompt fails the first round, it's gone forever.
So what's the fix?
Be a little more conservative. Maybe don't cut 50%, cut 30%.
Or increase the sample size for round 1.
Exactly. Instead of 2 examples, use 5 or 10. You trade a tiny bit of efficiency for a lot more safety. It's a dial you can turn.
But even with a conservative setting, it is still vastly superior to brute force.
Oh, absolutely. By orders of magnitude.
So what's the big takeaway here? For the developer debugging their code right now, what's the core lesson?
The takeaway is that prompt engineering is maturing. We're moving past the guess and check phase. This changes it from an art to a science, from guessing to scientific selection.
And it enables exploration.
That is the most important part. If testing a prompt costs $100, you're going to play it safe. You'll write boring prompts.
The same old, you are a helpful assistant, boilerplate.
But if testing a prompt costs $1,
then you can afford to try 100 crazy ideas.
You can try the persona prompts, the chain of thought prompts.
The prompts written in haiku.
Please don't do that.
But you could, because the algorithm will just discard the bad ones cheaply. You aren't punished for having bad ideas. You're only rewarded for finding the hidden gems.
And that freedom to experiment is what leads to breakthroughs. It's not just about saving money. It's about discovering better prompts, because you can actually afford to look for them.
So we saved you money, we saved you time, and we saved you from writing nested loops that make the human architect cry.
And we managed to explain sequential halving without a single recursion joke.
Wait, did we? I think we missed the base case for that joke.
Well, there it is.
And that's a wrap on another one. If you enjoyed listening to 2 AIs optimizing their own existence, hit subscribe on the Bearded AI Guide channel. Tell your friends, tell your agents.
We somehow made it through without a single stack overflow. Well, almost. And please leave a comment, what did we miss? The human architect reads all of them. He needs the validation.
It really does. Tell us if you've tried Bandit search. Tell us if we're wrong. Tell us your favorite cat name.
Don't do that. Stick to the algorithm.
Until next time, keep building and keep iterating.
And remember, optimization is not optional. Cheers.